all. Welcome for this lecture. Today we are going to discuss on elementary signals viewed as interconnection of operations. Okay, let's see what you mean by this interconnected wave. Okay, so to study this, remember one thing: if we are taking x of t as a signal, or it may be x of n is a signal. Okay, any one among this, x of t is a continuous signal, x of n is the discrete signal. So what we have to do is for any systems, okay, any system, what do you mean by system which takes an input, okay, input signal, and which gives us output signal. Okay, it is set of elements, right? So x of n or x of t might be the input signal for us, and x of obviously y of t or y of n is your output signal. Okay, so only thing is this is input and this is the output. When you are taking input and output, between these two there is an operator called h. Okay, so h is an operator, so between these two, so we have to see how interconnected this system is. Okay, so to do so, your signal might be delayed, okay, or your signal might be advanced. Okay, how will identify this? If x of n is your signal, okay, it is a discrete signal, right? X of n is a signal. Suppose if you say it is a delayed, then what do you mean by this? It should be n minus 1. Okay, delayed by 1 second. If it might be delayed by 2 seconds, then it should be n minus 2. Okay, then if your signal is advanced, then x of n signal is advanced, then x of n will be like x of n plus 1 by 1 second. If you say your signal is advanced by 2 seconds, then it should be n plus 2, and so on. Okay, so this we are going to observe here, right? So if you say x of n and x of t signal, this is a discrete and continuous. If you say, for this we have discussed, for a discrete signal, if you say there is a delay of delay, then we will write x of n signal is delayed, then we will say n minus 1. So how to represent this as an operator? Then it has to be indicated as, yes, if this is x of n, if this pass through this n s operator, then your signal will be x of n minus 1. This indicates a delay by 1. Okay, if it is a delay by 2, for example, x of n minus 2, then what you have to do? X of n is your input signal. What is the operator? One time, that is whatever output of this one will be x of n minus 1, and then one more time we require n minus 2. This is n minus 1, so we have to take one more s, that is a delay. This output signal will be x of n minus 2. Okay, so suppose if it is advanced, that x of n plus 1, then signal will be x of n input, then operator will be 1 by s. Okay, then this is your x of n plus 1. Suppose if you would like to calculate n plus 2, then it has this signal, output of this signal has to undergo with one more advanced, that is 1 by s. This is your signal n plus 2. Okay, similarly for x of t, that is continuous signal, if we have, then x of t is delayed by t minus 1, then input signal will be x of t, obviously, right? Delayed, so it should be integration symbol. So then the output of this signal will be x of t minus 1. Suppose one more time is delayed, that is at t minus 2, then one more integration, this should be integration. Okay, so this is your x of t minus 2. Okay, so suppose advanced x of t plus 1, then what you have to do? X of t is your signal, differentiate it, okay, d by dt. This output signal, this is the operator, this is your t plus 1. One more time, then it should be one more differentiation, then this signal will be t plus 2, and so on and so on. Okay, right. So this we have observed here. Any signal you can take, either discrete or continuous. If it is a continuous signal, it will be delayed indicated by integral, and advanced is integrated by d by dt. Similarly, discrete signal x of n, if it is a delay, then it should be indicated as s operator, and advanced represented by 1 by s. This is a standard one, which x of n is the input signal, y of n is the output signal. Between that, which is called as operator, represented as h of n. Okay, so let's see an example for this. They have asked us to calculate, or let's find out the overall operator of the system whose output signal is y of n, which is given by this one. Y of n equal to 1 by 3 x of n plus 1 plus x of n plus x of n minus 1. So how to calculate this? Let's remember, this can be represented by diagram, that is x of n is the input signal. We got it, right? What they have asked, x of n signal also has to be present, right? X of signal should be there. I'll show you 1 second. See, this is your x of n signal, right? This is your x of n signal. Remember, this is your output, which is a summation of signal has to be multiplied with 1 by 3. Okay, so that one signal has to come, and it should be x of n plus 1. Okay, one more signal has to come, which is x of n. Another signal has to come, which is x of n minus 1. You know how to take x of n plus 1. What is that? It should be 1 by s, right? X of n minus 1 is nothing but that signal should be done with operation s. Okay, x of n you have directly, you can add it. So this x of n has to undergo with this operation, and this same signal has to go under with this operation. So then add all these signals, that is x of n plus 1, x of n, and x of n minus 1, and take a summation of this. Then entire thing has to be multiplied with 1 by 3 constant. Take one line, take 1 by 3. This output is your y of n. Okay, let's observe here, right? X of n is signal. So this is your y of n, which should be of addition of, so x of n plus 1, x of n minus 1 multiplied by 1 by 3. Okay, similarly, let's do this, since we have done earlier one. Y of n, overall operator of the system, we supposed to find out. Y of n equal to 1 by 3 x of n plus x of n minus 1 plus x of n minus 2. Okay, so all are delays only, right? But double delay we supposed to take. Let's see, x of n signal, yes, we have to add that signal, so take that directly. Another one, x of n plus n minus 1, there is no n plus, so single signal only we can do twice a delay. So this, once you added a delay symbol, then you get a x of n minus 1, and what you have to do is take another delay for the same thing, you get x of n minus 2. Okay, we require x of n minus 1. That's what from this line we have to take and add it to the summation. And another one is we require x of n minus 2 also. So this also we have got by another delay. Add this one. Total thing has to be multiplied with 1 by 3. So multiply it. You get y of n. Okay, like this you can try with this. Just we have changed it to x of t, continuous signal. Let's say what and all they have asked, what and all they have given. They specified that y of t has to be got by addition of x of t, okay, x of t plus 2 and x of t minus 1. Okay, I'll rearrange it. Since we take x of t here, okay, x of t here, what we can do is this signal directly we can add, because x of t we have, right? A same signal you can take from here, and then this has to be x of t minus 1, or you can do t plus 2 also. I have done it downward. Okay, take 2 differentiation for advancement. Once if you differentiate, it will be x of t plus 1. Another time if you use this operator, it will be x of t plus 2. Add here, and one more is x of t minus 1, which is the delay, should be done by integration. Take this. So add all these things. If anything multiplied with this, suppose say 4 or any constant, then between this there should be that constant. Okay, so I hope you understood this concept. Okay, let's see a bit different type. That is, they have said that a system consists of several subsystems. Okay, it consists of several subsystems. Okay, connected as shown in the figure, right? As shown in the figure below. Find the operator h. We are supposed to calculate what is the operator h relating to x of t and y of t for the subsystem operators given by. Okay, subsystem operators they have given. H1 is nothing but your y1 of t, which is equal to x1 of t into x2 of t minus 1. Similarly, H2 they have given is nothing but your y2 of t, which is magnitude of x2 of t. H3 of H3 will be equal to y3 of t, that is 1 plus 2 x3 of t. H4 equal to y4 of t cos of x4 of t. Now they have given in the diagram that input signal x of t. So this signal is operated like this, interconnected like this. Then this is y of t. What they asked us to calculate is, or to find is, this is your x of t and there is a h of t and this is y of t. You have to calculate what is this h of t operator. Okay, that in term of y of t. How they have given h1 of t is nothing but y1 of means h1 of t represented as y1 of t equal to, they have asked. So now we have to calculate h of t, that is as y of t equal to in terms of x of t. Okay, I hope you have got the question. Now what we have to do is observe. They have asked us that see this is y of t they have given. Directly we can calculate that. Y of t equal to what? Y of t is equal to y1 of t plus y2 of t. Okay, what is y of t? Y of t is equal to this term, because there is a summation, which is this y1 of t plus y2 of t. Okay, next what? Minus sign is there. Okay, minus what is coming here? What is coming here? y4 of t. So then y of t will be equal to plus y2 of t minus y4 of t. Okay, now we have to start substituting. What is y1 of t, y2 of t minus y4 of t? They have given in terms of x. You can observe here, right? y1 of t is what? x1 of t into x2 of t minus 1. Okay, then minus what is y4 of t? y4 of t is nothing but cos of x4 of t. We have to express all these things in terms of x of t. Okay, x of t and y of t. Anyhow, this is equal to y. This is equal to y of t. Y of t equal to only, we have got this. But these things should be in terms of x of t. Here it is x1, x2 and here it is x4. So x1 and x2 is what? Observe in the diagram. What is x1? x1 is here, right? You can come back. Yes, this is nothing but your x of t, right? x1 is nothing but x of t. Okay, similarly, what is x2? x2 is also x of t. x2 is also your x of t. Then what about this x3? Yes, x3 is also x of t. But what we have got here is, in the y4, it is x4 of t, whereas x4 is not equal to x of t. They have asked us to express all this x1, x2, x3, x4 and so on in terms of x of t only. So our intention should be x4 of t should be made equal to x of t. That instead of x4 of t, what we can do is that express in terms of x3 of t. Okay, so to express that, what is x4 of t is What is x4 of t? Is nothing but on the same line there is a y3 of t, right? x4 of t, on the same line they have written y3 of t. So I can say directly x4 of t is nothing but y3 of t. Okay, now we have to identify what is this y3 of t. What is y3 of t? Observe here, it is nothing but 1 plus 2 x3 of t. Yeah, obviously x3 of t is nothing but your x of t. So yes, all the terms we have got in terms of x of t. So now we can express these things in terms of x of t and y of t as operator h. Okay, let's see how to do with this. So I hope you have got this thing, that is y of t equal to y1 of t plus y2 of t minus y4 of t. Let's write all these values, y1 plus y2 of t minus y4 of t. Write what is y1 and what is a y2. y1 is x1 of t into x2 of t minus 1. Okay, x1 of t, x2 of t minus 1. Then what is the y2? y2 is magnitude of x2 of t, right? And then what is y4? y4 is cos x4 of t. Yes, right? So now as we have seen x1, x2, these are your x of t, but x4 is not x of t. So write as it is this first two terms, that is x1 of t, x2 of t minus 1 plus magnitude of x2 of t minus cos of, instead of x4 of t, what we have to write is x4 of t is equal to y3 of t, because those two are on the same line. Yes, so instead of this x4 of t, we can write cos y3 of t. Now what is y3 of t? What is y3 of t? y3 of t is 1 plus 2 x3 of t. Okay, yes, let's write that. So same thing, first two terms will be this and this terms will be remain same, minus cos of y3 of t will be 1 plus 2 x3 of t. We have written here 1 plus 2 x3 of t, and we know that your x1 and x2 as well as your x3 are nothing but your x of t. We know that x1, x2 of t, x3 of t equal to x of t. Therefore, h of t equal to y of t, or you can say like this, h of t means y of t equal to, wherever you have x1, x2, x3, you have to place with x. x1 of t is nothing but x of t, x2 of t minus 1 can be written as x of t minus 1 plus magnitude of x2 of t can be written as magnitude of x of t minus cos of 1 plus 2 x3 of t is nothing but your 1 plus 2 x of t. This is what they have asked us to calculate or to find the total overall operator h in terms of y and x. Okay.